Hello friends, this is part 2 of Kuttaka, Bhavana and Chakravala method, a computational aspect. In the first part, we discussed problems on Kuttaka, and now in the second part, we discuss Bhavana and Chakravala method to solve quadratic indeterminate equation. Here we discuss the Chakravala method of solving the quadratic indeterminate equations of the type nx square plus or minus k equal to y square, where n, k are positive integers and capital N is not a square. If capital N is a square or n is a negative integer, then the equation has only finitely many solutions. And in this case, where n, k are positive integers and n is not a square, there are infinitely many solutions. The Indian mathematicians called it Varga Prakruti. A particular case of the equation nx square plus 1 equal to y square is presently known as the Pell's equation. Of course, there is no contribution of Pell to this equation, but by some confusion to the Euler, he gave a name to this equation as Pell's equation. Brahmagupta was the first Indian mathematician who deal with such equations. Brahmagupta's method is based on his principle Bhavana, which is the meaning of Bhavana is composition. Brahmagupta, in his famous book Brahmasputa Siddhanta, discovered that an integral solution of nx square plus k equal to y square can always be found if k equal to plus or minus 1, plus or minus 2 and plus or minus 4. From the integral solution of the auxiliary equation nx square plus k equal to y square, where k is minus 1, plus or minus 2 or plus or minus 4, one can always find an integral solution of nx square plus 1 equal to y square that we should see. Capitalizing on the work carried out by Brahmagupta, Bhaskara too invented the Chakravala, means cyclic method, to solve Pell's equation, and this is the landmark in the history of ancient Indian mathematics. Let us discuss Bhavana principle. There are two types, additive or subtractive Bhavana. Let a1 b1 and a2 b2 be the set of solutions of nx square plus c1 equal to y square and nx square plus c2 equal to y square respectively. Then a1 b2 plus a2 b1, b1 b2 plus n a1 a2 is a solution of nx square plus c1 c2 equal to y square. So if we write this in the vertical form, then it is easy to remember. So a1 b2 means cross product plus a2 b1. So if we take plus, then it is additive Bhavana. If we take minus, then it is subtractive Bhavana. So from two solutions of two equations, we get the solution of the third equation. This additive or subtractive Bhavana is also known as Brahmagupta's identity. So y square minus nx square equal to c1 c2, but what is c1? c1 is nx square minus y square and c2 is nx square minus y square from the second equation. So this is called Brahmagupta's identity, which is nothing but additive or subtractive Bhavana. Then there is another Bhavana called Tulya Bhavana. In this case, if you consider the second row as same as the first row in the additive Bhavana, then we get Tulya Bhavana. So Tulya Bhavana is a special case of additive Bhavana. So here, if a1 b1 is a solution of nx square plus c1 equal to y square, then 2a1 b1, b1 square plus n a1 square is a solution of nx square plus c1 square equal to y square. This is very useful for solving examples. Now let us discuss some concrete examples. Consider the equation 14x square plus 1 equal to y square. Then a suitable auxiliary equation is 14x square plus 2 equal to y square, and with solution of this equation is x equal to 1, y equal to 4. We can easily find solution of this equation. Then by Tulya Bhavana, we can find solution of the equation 14x square plus 4 equal to y square. And now we can divide both sides by 4, and we get the solution of the original equation 14x square plus 1 equal to y square, and the solution is x equal to 4 and y equal to 15. Consider another example 31x square plus 1 equal to y square. Now observe that the suitable auxiliary equations are 31x square minus 6 equal to y square. It had solution x equal to 1, y equal to 5, and 31x square minus 3 equal to y square had solution x equal to 2, y equal to 11. Now it is difficult to choose auxiliary equations, two auxiliary equations, especially the second auxiliary equation. Look at the second equation. It is not easy to guess the second auxiliary equation. But now from additive bhavana, from these two solutions, we can find the solution of the third equation, which is 31x square plus 18 equal to y square. Then dividing both sides by 9, we get 31x square plus 2 equal to y square. Now we can use Tulya Bhavana, and then we can find solution of the equation 31x square plus 4 equal to y square, and then dividing by 4 we get solution of the original equation, which is 31x square plus 1 equal to y square, and the solution is x equal to 273, y equal to 1520. The problem in the method Bhavana is first we have to guess auxiliary equations, and it is not always easy to guess the suitable auxiliary equations. Now let us see one application. All positive integer solutions of nx square plus 1 equal to y square are given by xn yn satisfying yn plus root n xn equal to y1 plus root n x1 raised to n, where x1 y1 is the fundamental solution. That means that it is minimal positive integral solution. Once the fundamental solution is determined, one can see that the other solutions are given by Brahmagupta's identity. So we can find all solutions. The sequence yn upon xn forms a sequence of best rational approximation to the irrational number root n. Interested readers can learn about this more afterwards. Now let us discuss the Chakravala method, and this lemma is invented by Bhaskara II. First consider the following lemma. If na square plus k equal to b square, then for any integer m we get this equation, and proof of this you can easily see by expanding the brackets. So you can easily prove that the left hand side is equal to right hand side. You can check this. Consider the concrete example 52x square plus 1 equal to y square. Now in this method there is no need of trial. You just check the nearest square. The nearest square is 49. So consider the auxiliary equation as 52 into 1 square minus 3 equal to 7 square. Then apply the lemma to this auxiliary equation and we get this. Suppose m plus 7 upon 3 equal to t is an integer, then m equal to 3t minus 7. If coefficients of m and t are sufficiently large, then you can use Kuttaka method to find the values of m. Now here we can easily find the values. For m equal to 8, m square minus 52 is numerically smallest. Numerically means you ignore the sign. Just mod m square minus 52 is smallest. Hence by taking m equal to 8, we get the auxiliary equation 52x square minus 4 equal to 36x square. And now the constant is minus 4, means we can use Tulya Bhavana. Now we can apply Tulya Bhavana method for this auxiliary equation, and then we get the solution of the equation 52x square plus 16 equal to y square. Then dividing both sides by 16, we get a solution of the original equation 52x square plus 1 equal to y square, and the solution is x equal to 90 and y equal to 649. Now consider again 31x square plus 1 equal to y square. We have already discussed this example by Bhavana method, but there finding auxiliary equations by trial is a difficult task. But now here in this case, the finding suitable auxiliary equation is easy. There is no trial. You find the nearest square and the nearest square is 36. So we get the equation 31 into 1 square plus 5 equal to 6 square. Now apply the lemma to this auxiliary equation and we get this identity. Now if m plus 6 upon 5 equal to 2 is an integer, then in this example we can find for m equal to 4, m square minus 31 is numerically smallest. So consider the auxiliary equation 31x square minus 3 equal to y square. Now minus 3 means we can't use Tulya Bhavana, so we have to again apply the same lemma to this auxiliary equation. So consider this auxiliary equation and apply the lemma. Then by similar steps we get for m equal to 5, m square minus 31 is numerically smallest. Hence we get 31x square plus 2 equal to y square, and now the constant is 2, so we can use Tulya Bhavana as before and we get the same solution 31 into 273 bracket square plus 1 equal to 1520 bracket square. In Bhavana method, we have to find auxiliary equations by trial, but in Chakravala method, you just find the nearest square and then consider that suitable auxiliary equation. Then you can apply the lemma again and again, but for finitely many steps, and finally using Tulya Bhavana when the constant is -1 or ±2 or ±4, then using Tulya Bhavana we get the final solution. So this is concrete algorithm. There is no trial method involved in Chakravala. Now these are some special cases. Consider nx square plus 1 equal to y square where capital N is in the form n square minus 1 for some n. Then this equation had solution x equal to 1, y equal to n. It is easy to see that. The equation 960 x square plus 1 equal to y square had solution x equal to 1, y equal to 31. Then this is another case where capital N is in the form n square plus 1 and the equation is nx square minus 1 equal to y square. Then this equation had solution again x equal to 1, y equal to n. Particular equation is 530x square minus 1 equal to y square had solution x equal to 1, y equal to 23. So if capital N is in the specific form, then we can directly find the solution. Then there are some identities which we can directly use to solve equation if capital N is in the specific form. So if capital N is n square plus 1, then the equation had solution x equal to 2n and y equal to 2n square plus 1. If capital N is in the form n square minus 1, then also we can find solution. If capital N is in the form n square plus 2, then solution is x equal to n, y equal to n square plus 1. If capital N is in the form n square minus 2, then the equation had solution x equal to n, y equal to n square minus 1. If capital N is in the form 4n square plus 4, then the equation had solution x equal to n, y equal to 2n square plus 1. You just substitute the values of x and y in the given equation and then you can find the left hand side is same as the right hand side. These are exercises and you can solve these exercises either by Bhavana method or by Chakravala method. This last example 61x square plus 1 equal to y square is given in the ancient time and solution to this equation is very large and that we can solve by Chakravala method. These are the references and I have taken material from these sources. You can read these articles later. Thank you.